Hello everyone, good morning. I hope all of you are good and I am also fine. So today I will take one class from chemistry. That is from the chapter structure of atom and from class 11. Okay, so this lecture will help you for the preparation of the board. Those are in class 11 and also for the preparation of NEET, JEE and NDA, TET, etc. Okay. So first I will discuss about the topics of Planck's quantum theory. Okay, Planck's quantum theory. So first I will explain the formulas and then I will take some numericals from the previous sections, NEET or JEE question from the topics. Those I am explaining here. Okay, so Planck's quantum theory, what explain? According to Planck, if energy is directly proportional to frequency, here energy is what, sir? Energy E means energy of each photon. Okay, energy of each photon. Nu is what? Is frequency of each photon or incident photon. Okay, so if I remove this proportionality, then we will get here one constant. This one is h, and this h is known as Planck's constant. Planck's constant. Okay, and the value of Planck's constant is 6.63 into 10 to the power minus 34 joule second, SI, in SI. Okay, in SI system, joule second, and 6.63 into 10 to the power minus 27 arc second in CGS. Okay, in CGS unit, the Planck's constant value of h is 6.63 in 10 to the minus 27 arc second, and in SI system 6.63 in 10 to the minus 34 joule second in SI system. Okay, now again we know that speed of c is light of speed, c is nu is c by lambda, where c is speed of light or speed of photon and lambda is what, sir? Wavelength of incident photon, wavelength of photon or incident photon. Okay, got my point? Fine. Now if I put the value of this nu in equation, suppose this one is one equation and this one is two equations. If I put the value of nu in equation 1, what will get? So from 1 and 2 we get E equal to AC by lambda, is not it? So this is the expression of energy of each photon. This is the expression of energy of what? Energy of one photon. Okay, so here now look at here, this one h and c are constant, so we can write here E proportional to 1 by lambda, and from that we can write E1 by E2 is equal to nothing but lambda 2 by lambda 1. Okay, got my point? Fine. Now this one is for single photon. Okay, if there are n numbers of photon are there, then what will be the energy of each photon, total photon? So if you just write note here, if capital N is the total number of photon, then total energy of each photon will be what? E equal to n into you just multiply with n, AC by lambda. Okay, from that you can find easily number of photons is what. So in numericals they sometimes given wavelength, you have to find out the energy of photon, or sometimes they given energy and wavelength. From that you have to find out the total number of photons is what. Okay, so write it down. Now next part, I will discuss the relation between kinetic energy or energy and power. Okay, the next topics will be the relation between energy and power. Now the relation between energy and power. So relation between energy and power. So if let E equal to energy of each photon, and then P is power of each photon, T is time taken, then N is total number of photons. So there is a relation between between power and energy. So we know that power is nothing but, power is what? The basic formula of power is energy by time, is not it? This is the basic formula you got in class 7, this formula. Okay, the power is energy by time. So power P, energy E, and time is T. Since there are n number of photons, so total energy will be Ne. Okay, so from that we can find number of photons will be P into T by E, right? Got my point? So from that relation we can find the number of photons emitted. Suppose sometimes they given in the questions asked there is a bulb of some watt and the total energy is this one or wavelength is this one, then from that find out in 1 minute or in 1 second or in 1 hour how many photons will be escape from this bulb. Okay, this type of question will came. Now I will give some questions. I will take some questions from the previous section, NEET or JEE, and from the related topics, that is power related and energy related. Okay, so let's try. So our first question is like that: if the energies of two photons A and B are 50 electron volt and 150 electron volt, then find the ratio of their wavelength. Okay, so the energy of two photons is given A and B is, the energy of A is 50 electron volt and energy of B is 150 electron volt. Okay, and we have to find out the ratio of their wavelength. So let's try. Here what is given? E1 is given 50 eV and E2 is given 150 eV. We know that 1 eV equal to what? 1 eV is nothing but 1.6 into 10 to the power minus 19 coulomb, is not it? 19 joule. Okay, 1 eV, 1 electron volt is equal to 1.6 into 10 to the minus 19 joule. Now since we have to find out the ratio, so no need to convert this electron volt into joule. So what is the formula? We know that the formula is E proportional to 1 by lambda. E, energy is inversely proportional to wavelength. So from that we can write E1 by E2 is nothing but lambda 2 by lambda 1. So therefore E2 by E1 is equal to lambda 1 by lambda 2. I just convert this one. Now lambda 1 by lambda 2 is what? E2 by E1. So it will be, E2 is what? 150 and E1 is 50. If I cut this one, it will be 3. It will be 3 by 1. So lambda 1 is to lambda 2 is equal to 3 is to 1. So which option is correct? Option B is the correct answer. Okay, so option B is the correct answer. This type of question is came in NEET and JEE. Okay, every year. If you look at the previous section, previous year question sections from the topic, you will get so many questions like that. Okay, so what is the correct answer here? Option B, that is 3 is to 1. What I am doing here, I just first write the E1 is given, E2 is given, and we know that the relation between energy and wavelength is E proportional to 1 by lambda, that is E1 by E2 equal to lambda 2 by lambda 1. So from that I find lambda 1 by lambda 2 equal to E2 by E1, that is 150 by 50. If I simplify this one, it will be 3 by 1, that is 3 is to 1. So which option is correct? Option 3 B is the correct answer. Okay, got my point? So move on the next question. So our next question, that is question number 2 MCQ, is like that: if the energy of a photon is 2 into 10 to the minus 18 joule, then find the wavelength of the incident photon. So the energy of a photon is given. In that case, we have to find out the wavelength of the incident photon. Okay. So what is given? We have to write first. Given energy is equal to 2 into 10 to the minus 18 joule. Okay. Next, we have to find out the wavelength. The wavelength we have to find out, question marks. Then H is what, sir? 6.63 into 10 to the minus 34 joule second as a system, and C is 3 into 10 to the power 8. Is not it? This is the speed of photon and the Planck's constant. So we know that energy is hc by lambda from Planck's quantum theory. From Planck's quantum theory, okay, PQT, Planck's quantum theory. We know that energy equal to hc by lambda. So from that, lambda is equal to what, sir? hc by energy. So h is 6.63 into 10 to the power minus 34. C is 3 into 10 to the power 8, and divided by energy is 2 into 10 to the power minus 18. Now, if you multiply this by this, it will be what? It will be 19.89, and here 10 to the minus 34 plus 8 divided by 2 into 10 to the power minus 18. Okay. Here is what? 19.89. We can write here is 20 into 10 to the power minus 26. Okay. And here 2 into 10 to the power minus 18. If I cut this one, it will be 10. And if I cut this one, it will be what? 10 to the power minus 14. Is not it? 14. Yes. 26 minus 14 or 4? 26 minus 18. 8. Sorry, 10 to the power minus 8. It will be 10 to the power minus 8. Okay. So, it will be 10 into 10 to the power minus 8. Or we can write 10, 1 0 and another 0 into 10 to the power minus 10. Okay. Is not it? 1 0 into 1, double 0 into 10 to the power minus 10. Okay. So, since, so lambda is equal to what? 1000 into 10 to the power minus 10. What I am convert this 10 to the power minus 10, because 1 Armstrong is 10 to the power minus 10 meter. Here all the questions, all the answers is given, option is given in Armstrong. That's why I convert this one in Armstrong. So lambda is equal to what, sir? 1000 Armstrong. So which option is correct? No one. First one is 2000 Armstrong. This next one is 1500, that is 1500. Next one is 3000 Armstrong, and D number is none of this. So which option is correct here? Option D is correct, because it's not matching with A, B or C. Okay. So it's so simple. Look at here. I just write energy H and C. After that, I put the value, that is the formulas of photon, E equal to hc by lambda. That after that, lambda equal to hc by E, and after simplification, I just multiply this by this into 19.89, and I add this to minus 34 plus 8, and if we get 10 to the power minus 26. If I cut this by this, it will be 10 to the minus 8, and here here is 10. I added 2 0 here, that is 10. I added multiply 100, and here I write 10 to the minus 10. Why? Because I have to convert this wavelength in Armstrong, since the answer is given in Armstrong. Okay. So what Armstrong is came? 1000 Armstrong is came. Since 10 to the minus 1 m meter, 10 to the minus 10 m meter is 1 Armstrong. Okay. So got one point. So move on the next question. So students, our next question is question number 3, and this is the last question of this lecture. Okay. And what I am explaining the theories here. From every topic I given one MCQ questions from the previous section. Okay. And this is the last question of this lecture for only today. Okay. So the question is like that: an electric bulb power is 100 watt. An electric bulb power is 100 watt. So here what is given? Power is given. Okay. So power P is 100 watt given, and the wavelength of radiated bulb. Suppose this one is one bulb, okay, and the photon is radiated from this bulb, that is light is radiated, okay. So wavelength of the bulb is what? 3000 Armstrong. So that is 3000 into 1 Armstrong is what? 10 to the minus 10 meter. It is 3 into 10 to the minus 7. Here is 3 and here is 10 to the minus 10. So it will be 10 to the minus 7 meter. Okay. Now total number of photons we have to find out. Time is what? 1 minute. Time is 1 minute, and 1 minute equal to 60 seconds. Okay. Now energy of each photon is what? Each photon will be E equal to Hc by lambda. So H is what? 6.63 into 10 to the power minus 34, 3 into 10 to the power 8 divided by lambda is what? 3 into 10 to the power minus 7. If I cut 3 by 3, okay, and energy will be 6.63 into 10 to the power minus 34 plus 15. So it will be 6.63 into 10 to the power minus 19 joule. Okay. So an energy is photons came out. Now what is the formula? This P equal to E into N by T. This is the formula. There is the relation between power and energy. Okay. From that we can find a number of photons N equal to P into T by E. So power is what? Power is 100. Time is 60 second. That is 1 minute equal to 60 second. And here is 6.63 into 10 to the power minus 19. Okay. So we can write 10 to the power 3, 6 into 10 to the power 3. Okay. And here is 6.63 into 10 to the power minus 19. So it will be, if I cut this one by this, it will be almost 1, is not it? So 1 by 1, and here is 10 to the power 3 plus 19. So that is 1 into 10 to the power 22. So it will be 10 to the power 22. Okay. 10 to the power 22 photons. So which option is correct? Option D is the correct answer. So number of photons emitted per minute will be 10 to the power 22 photons. Okay. 10 to the power 22 photons. So which option is correct? Option D. Since option A is given 100, option B is given 800, option C is given 120, and option D is none of these. So which option is will be correct here? Option D is the correct here. Okay. So let me explain again in short. A electric bulb is given. In here power is given what? 100 watt, and the incident photon wavelength is given 3000 Armstrong. So from that relation we have to find out, and time is given 1 minute. In 1 minute how many photons is came out from the electric bulb? This one is the question we have to find out. So first we try to find out the energy of each photon, that is E equal to Hc by lambda. This one is 6.6 in 10 to the minus 19 joule. Then we use the formula, that is P equal to E into N by T. So N equal to P into T by E. I just put this value, and this one I write this one is 6 into 10 to the minus 10 to the plus 3, and if I cut this by this one is almost 1, near about 1, that is 6. 1.1 means 1. So 1 by 1 into 10 to the power 3 plus 19, it will be 10 to the power 22. So total number of photons emitted from the bulb is equal to 10 to the power 22. Okay. So this much for today. I hope you enjoy my class, and if you have any doubt you can leave a comment in the comment sections. Okay. So thank you for watching. Have a nice day.